So we're going to keep going with more Taylor series FRQs.
Mm-hmm.
Hoping to take another look at Lagrange error bound, and then we'll go through another free response question with radius interval convergence. So the only thing I want to do is take a look at this formula again and point out what's happening to this b. So Lagrange error bound says if I want to find how wrong a Taylor series approximation is going to be, then I can take whatever the next term in the series would be, so that's the n plus 1 derivative, at the n plus 1 point around the center, and maximize it. So if this next term had been the sine of something, then we would maximize that error at plus or minus 1.
Mm-hmm.
Okay, so the reason this b is not c, so I'm not actually centering around the center point anymore, is because we want our error to be as wrong as possible.
Mm.
Okay. Any questions on error bound?
Nope.
Okay, we'll try one. Okay, so we've got our Taylor series at x equals 1 converges to f of x for all x in their interval of convergence. We know f of 1 is 1 and the first derivative is negative 1/2. The nth derivative is given by this formula. I wanted to write the first four non-zero terms. What would I have to do?
So you plug in 1, 2, 3, 4 instead of n.
Okay, so that's going to give us the derivatives, right?
Mm-hmm.
Okay, so we'll get those derivatives first. We were told our constant here, so I'm just going to start there. F of 1 is 1, and f prime of 1 is negative 1/2. Okay, we're given those two. What's the second derivative?
Um, that's plug in 2. So 2, 1, 4 over 1.
4 of 1. Okay, if I plug in 2, this would be negative 1 squared is 1, and then the 2 minus 1 is 1 over 4.
Mm-hmm.
Okay, I think that's a language difference, right?
Yeah.
Oh, okay,
Oh
cool.
yeah, 1 over 4.
1 over 4.
Yeah.
Okay, cool. And then the third derivative?
Third is minus 2 factorial over 8.
Okay, minus 2 factorial is just 2 over 8.
2 factorial is 2.
Okay, cool. And then I need to take this and make it a function. So once we've got these derivatives, we'll need to multiply by x minus 1 raised to the n power and divide by n factorial.
Mm-hmm.
Okay, so what's f of x?
So since the bottom part is increasing by like square, 2 square, 2 to the x power.
I don't think we're quite there yet. General form for Taylor series, I'm going to write up here. Actually, can you tell me, what is the general form of a Taylor series?
F to the nth power times b, a or x minus a. And what was it? Oh, then x minus a factorial.
Not yet. X minus a raised to what power?
Nth power
Nth power? Over...
over x minus a factorial.
no center point, actually. So this is just n factorial.
Oh yeah, n
So
factorial.
that bottom part is because we keep deriving, you would multiply by the power. So to work backwards, I'm going to divide by all of those. This nth derivative of f is going to give me my coefficient. So this nth derivative of f is really what we're seeing here. This f of 1 is this part. And then you're going to multiply by x minus a to the nth power. Okay, so my first term, I'll do the first two terms, if you can do the last two terms. My first two term is 1. Since this would be x minus a to the 0 power over 0 factorial, plus my first derivative, negative 1/2,
Mm-hmm.
times x minus 1 to the first power over 1 factorial. Okay, what would the next term be?
1 over 4 times x minus 1
Okay,
over
I'm going to do this actually. X minus 1 raised to what power?
raised to the second power over 2 factorial.
Okay, and last one?
Minus 1 over 8
Okay, so that's a 2, but this would be minus 2 over 8 times...
x minus 1 to the third power and divide by 3 factorial.
Okay, so let's simplify things just a little bit, and we'll see if we can find a pattern.
Mm-hmm.
Okay, so what's 3 factorial?
That's 6.
6. Okay, and 6 is 3 times 2, so this 2 can cancel. So that leaves us with 3 on bottom. Then this sign can cancel, and I think that's it actually.
Mm-hmm.
Okay. So, do you see any patterns?
Yeah.
Okay, what do you see?
So that's minus
Give myself a bit more space than that so I can write. Keep going.
isn't it 1 over 1 over 2 to the x power for the first? Oh wait, we just write in general form, so that's f to the second power. No, f to the nth power.
I'm looking for a general form for the pattern, so I'm not looking for the Taylor series. So for instance, if I want to look at this alternating part, how could I make this alternate?
I don't know.
Okay, so this would be negative 1 raised to some power. For this first term, I'm positive. So if I want to start
Because that's
positive,
n minus 1.
n minus 1 works, okay. Then I'm going to multiply by x minus 1 raised to what power?
N minus 1.
N minus 1 again, okay. Divided by, okay, I need a pattern for everything that's happening on the bottom.
Oh, that's n minus 1 factorial.
Um, it could be, except we don't have a factorial anymore for this one.
Mm. Oh, that's just n minus 1. Because we start from 0. Oh, wait, it's 1.
Okay, I can take n minus 1. Um, that won't work for the first term, you're right. Um,
No, it's 1, 2, 4, 8, isn't it?
right. 1, 2, 4, 8 for the bottom numbers, and then we're also going to have an extra n minus 1 to multiply, though, after the first term.
No.
So, I'm going to have to pull out that first term, unfortunately. 1 plus. Okay, so I'm going to change this. Instead of n equals 1, this will be n equals 2. So I'm dealing with the second term.
Mm-hmm.
Um, so everything else still works, right? And this will be negative 1 raised to the first power, which is negative 1, x minus 1 to the first power, and n minus 1. Okay, and that should work. Okay, then we can keep going. You saw a pattern here just a second ago. 2, 4, 8. What's that pattern?
4, 8 is 2 to the n power.
Okay. 2 to the... Okay, if I just do the n power right now, I'll be starting at 2, so that would be
Oh, n minus 1.
n minus 1. Okay, and that should work.
Mm-hmm.
Okay. So, check before we move on. Okay, we've got our first two terms, we're good. Our third term and fourth term, okay, that's good. Our general term, okay, so they kept going for their general term will be what happens for the next. I actually like what we have better, because our general form goes all the way back to the start. But we should get full credit for that. See if I can paste this into the next part really quick. We've got it for the other slide. Take out general form and throw that here. Okay. Can you still see?
Mm-hmm. That's the new one?
Yep. So we just finished A. So I'm going to go to B. We have a radius of convergence of 2. I want to find the interval of convergence, and then show the work that leads to the answer.
Mm-hmm. So, yeah, we just plug in 1, 2, 3, 4 as well.
If I'm looking for
Oh,
interval
wait.
of convergence with a radius of 2, and I'm centered at 1, then what's my interval?
Oh, so we do n plus 1 and then divide by the original function.
Okay, right now we've got our Taylor series is centered at 1.
Oh, so it's x minus 1 and then absolute value is less than 2, right?
If my radius of convergence is 2, then that means my total interval should be how much?
2 or 4.
4. Okay, so this should go from what number to what number?
-1 to 3.
From -1 to 3. Okay, then we need to test the endpoints. So
Yeah.
we already know it converges for all of these.
Mm-hmm.
Okay. So to test the endpoints, we're going to plug in -1 into our general form and see what happens. Okay, so if we do, when I plug in -1 in here, what's going to happen?
It converge.
Okay, converges by which series?
You mean test?
Yeah.
So I chose the geometric.
Okay. -2 to the...
Yeah, -1. That's -2 to the
I
factorial.
should keep this. -2 to the -1, -1. Okay, so we've got these two negatives here, and those are going to cancel, which will make this positive. So I've got +2 to the n-1 on top, 2 to the n-1 on bottom,
Mm-hmm.
and then n-1 on the bottom. These two will cancel, so I'm left with 1 over n-1. If I keep going... If I keep going forever, will this series converge or diverge?
That's Oh wait, that's diverge, isn't it?
This one does diverge. Okay,
Yeah.
diverges by which test?
CDT? What is it? Comparison direct test by 1 over n.
By a smaller number. Okay, that works. dct to 1 over n. Okay. So that's at x equals -1. Okay, we're going to do the same thing at x equals +1. If x is +1, then this negative does not change.
Mm-hmm.
So this will be 2 to the n-1, 2 to the n-1, and n-1. Okay, once again, my 2 to the n-1s will cancel. So I'm left with an alternating series this time.
Yep.
Do we converge or diverge?
It converge.
Converges. Absolutely or conditionally?
Conditionally.
Conditionally, okay. But for our purposes, this one just converges. So I've got an interval of convergence that looks like this.
Mm-hmm. An empty circle at 1.
Yes. So if I wanted to write this, we could say our function converges on -1 is less than x is less than or equal to 3. Okay, any questions on what we did there?
Nope.
Okay, we'll check really quick. Okay, harmonic series diverges, this series diverges. Okay, cool, we identified both endpoints, looks good, and alternating converges. Okay, so we're good. I'm going to go back and copy over our formula one more time. Come on. Okay. So for part C, I want to estimate 1.2
Mm-hmm.
to approximate our Taylor series. So if I do, I've got our Taylor series approximation here. What do I need to do?
Mm, you plug in 1.2 from general term of series that we did in 1, isn't it?
Okay, so I've got our whole long form here because I thought that would be easier to plug into. Um, so if I plug in, then my first term is going to be what?
1,
1. Okay, what's my second term?
that's minus 1/2 times 0.2 divided by 1.
Okay, 0.2 over 2.
Mm-hmm. And then plus 1/4 0.2 squared divided by 2.
Okay, so I'm going to go 1 over 8, and this will be 0.2 squared.
Mm-hmm. Oh, and then, yeah, keep going.
Okay, can we simplify it all?
Simplify.
Yep. So what is 0.2 over 2?
Mm, that's 1/10. Wait, let me calculate.
So we won't have a calculator for this section, unfortunately.
Oh,
That
wait,
is 1 over 10.
that's 2/10. Oh, 0.1. Yeah,
Yeah, that's fine. Either way.
and
So,
0.04 divided by 8.
okay. I still need to work with that though.
That's 5/1000. That's 0.1.
Okay. If you're not sure, we can do 0.2 is 2 over 10, right?
Mm-hmm.
So I've got 2 over 10, 2 over 10, and 1 over 8, if that helps you. So what would this simplify to?
That's 800. 4/800.
Okay, what does that simplify to?
Oh, 1/200.
Okay, cool. 1 over 200. Okay, so again, we're not going to have a calculator on this section. So I would keep things in fractions. I think those are easier to work with. Okay, any questions on this one?
Nope.
Cool. There's our approximation. Okay, they did give us decimals here, but we've got the same numbers. Then I want to prove that this approximation is within 1/1000th of the exact value of f of 1.2.
Mm-hmm.
Okay, so if I want to look for my error, I can say the absolute value of our approximation minus the actual series should be less than or equal to what for my error bound? Let me go back and I'll paste our function here again. Okay, so for our error bound, what should this be?
Mm, so we're doing D, right?
Yes.
And then we simplify the
Sorry.
hmm show that the approximation found it. I don't know this one. It was D is like hard always for serious to me.
So we just got the first three terms.
Mm-hmm.
So with our error bound from today,
It should be greater 4.
okay, I should be looking at the fourth term. Okay,
Yeah.
so here's our series again. 1, 2, 3, 4, the fourth term. How would I
Mm-hmm.
find the error using that term?
So we add. So we find. Oh, it should be less than fourth term.
Right. So at 1.2, what will the fourth term be?
F. Um. So it's f to the fourth power 1.2.
Okay, so I'm going to circle up here. This is our fourth term,
Mm-hmm.
if that makes it easier.
Oh, and then 1.2 plug in there.
Okay, so what happens when I plug it in?
Oh, we get um 1 over 4, 1 over 4, 1.2, 1.2, 0.2 to the cube
Okay,
over 3.
0.2 cubed. There is a 3 on bottom, but we still have one more term on bottom.
12. No, 24.
Okay, total on bottom is 24. I'll take that. So that 2 canceled, the 3 canceled, so I was left with the 8 by 3. Okay, so I'm going to rewrite this as a fraction, and we'll see if we can simplify. So 0.2 written as a fraction is how much?
0.2 cube?
What is 0.2 as a fraction?
That's. Wait. 1 over 5.
1 over 5. So I have 1 over 5 cubed.
Mm-hmm.
Times 1 over 24.
Yep. So that's 1 over 25 times 24.
Okay, 1 over 25 times 24. Um, what is 25 by 24?
Isn't 1 over 125?
Oh, yeah, I'm sorry.
And then we
The
multiply
street,
the
not square.
number.
Okay. So if I want to do this by hand, maybe we could either multiply like
Do that,
this
but
and then add, or you can multiply 125 by 20 and then add 125 by 4. How would you do it if you did not have a calculator?
um, so I do like 5 times 4 is we get 0, and then 8 times 2 plus 2 is 1. No, yeah, it's 10, so write 0 and then 5. And then we write it in the other one. 0. Like we write it in last, we write it from last second line. So it's like 0, 5, 2, we get 3,000.
Okay, cool. Cool. So this is 1 over 3,000.
Mm-hmm.
Okay. So we've just proven, I'm going to write over here somewhere. that the difference between our approximation and the actual value at 1.2 should be less than or equal to 1 over 3,000, which is what they wanted us to prove. This says we're within 1 over 1,000.
Mm-hmm.
1 over 3,000 is within 1 over 3,000 for our range, right?
Mm-hmm. Wait, what is T 1.2?
That would be the actual value. So this Taylor
Oh.
series is approximating a function, right?
Mm-hmm.
So our approximation, our guess, minus the real value, should be less than or equal to our error. Okay, I'm going to erase our multiplication over here on the side. To say that 1 over 3,000
Uh-huh.
is less than 0.001. So our error, I'll say, so our approximation is within 0.001 of f of 1.2.
Mm-hmm.
Okay, any questions on what we did there?
No.
Okay, and we'll see what we got. Let's see, -1, 8 there. I did not put a negative here. There is a negative there, so I did miss a negative with the absolute value that didn't actually change anything though for our math. Okay, so we got error form and analysis. Okay. Any questions on anything from this one?
No.
All right. So I've got 3 more free response questions for the next class period, which would be Friday.
3?
Yep, so there's 3 free response questions. They're all from 2009 without a calculator. There are 2 questions that involve Taylor series
Oh,
for parts of it.
4 to 6?
Yep, so I only want you to do 4 through 6.
Oh, okay.
And then on Friday, we'll go do the other 3. So
Uh-huh.
if you want to get ahead and don't want to have homework for the weekend, you can do all 6 and just submit 4 through 6 on course sites for Friday, and then 1 through 3 on course sites for Tuesday.
Oh,
If you
1 to 3 will be homework for
wait,
holiday?
1 through 3 will be homework for the weekend.
Oh, okay.
Okay. Any questions on anything before we break?
No.
All right. Thank you very much for coming. I'll see you tomorrow.
Bye-bye.
Goodbye.